first, I'm going to go over
What are like terms? Like terms will be those terms that have the same variable and the same exponent on the corresponding variables.
when you combine like term, you add the coefficient. Okay, so 2 plus 3 is 5. Okay, and then AQ plus AQ, this is still AQ. The exponent on that doesn't change. Okay, because you think about apple plus apple, okay, you still get apple, right? You don't get something else, right? Similarly, these two are like terms. They have the same variable and same exponent on each corresponding variable. Okay, so when you combine them, you combine the coefficient. 3 plus 4 is 7. So 7ab squared CQ. Okay. Now these two are not like terms because what? Can it? Because they have different exponent, right? Okay. So you will leave them alone. Okay. You cannot combine them. You cannot combine them by addition or subtraction. Now to combine like term over here, these two are like terms. You combine the coefficient right here. I need to convert them to the same denominator. So how can I convert them so that they will have the same denominator?
Would you find a common denominator?
Yes, you find the least common
Like
denominator.
6?
Yeah, thank you. So you find the least common denominator. Over here it is 6. Yeah, you got it. So we multiply. Okay, down here I have 2. Here is 3. So to make a 6, so I have to times this by 3. Okay, so we times by 3. But whatever you multiply down here, you need to multiply this up here by the same number. So multiply that by 3. Similarly, this one here, to make the denominator to be 6, I need to times 2. And I had to do that. I had to multiply by 2 up in the numerator also. Because when you multiply 3 over 3, it's the same as multiply by 1. So multiply by 1 is not going to change the original number. Okay, all right. So when you have, now over here, this become negative 3 over 6. This become 2 over 6. Now they have the same denominator, so we can combine them. So we keep the 6 in the denominator. And then negative 3 plus 2 is negative 1. So we put negative 1 over here. Another way to write this is, see the AB here? It's actually should be in the numerator, okay? It's the same as AB over 1. So you put this AB on top. So negative AB over 6, okay? Number 2, this one here, you need to distribute first. Distribute the 6, okay? So you will have this 6 times 3 over 2a minus 6 times 4 over 3 plus, over here, the 6 over 6 here will divide out, okay? So leaving you with 5a. Here, the 6 over 2 will be reduced, okay? It become a 3. 6 over 3 is a 2. Now you multiply, okay? So 3 times 3a here is 9a. And 2 times 4 is 8, and then plus 5a. Now you have this 9a plus 5a, which is 14a. And now you will, the negative 8 here is by itself, so you have this, okay? All right, any question? So the next one I'm going to review here will be solving equations. Give you a heads up, okay? A quiz is coming next week, okay? So either in class or on website. To solve this equation, we see that this has this fraction 3 over 4 and times x here equal negative 7. I want to solve for x, so which means I want to have 1x on the left side and number on the other side. Now I need to make the coefficient of x here become a 1. So I'm thinking, what can I multiply with 3 over 4 so that the coefficient here will be 1? What number do I multiply here? So I will get a 1. Anyone?
4 over 3.
4 over 3. Yes, you got it. Okay. So 4 over 3 This is the reciprocal of 3 over 4. Okay, so when two reciprocal multiply, you get a 1. And 1 times x here, you don't need to write a 1, you just put x. Okay. Now, whatever you multiply on the left side equation, you need to multiply that to the other side equation, so to balance the equation, right? So we multiply this with 4 over 3 on the right side also. Now over here, negative 7 times 4 is negative 28, okay? And then 3 in the denominator. Okay, now we have isolated this x, we solve for x. Okay. Now this next one over here, okay, 6 times this. Now for this equation over here, first you need to remove the inner parenthesis first by distributing this negative sign, okay? So distribute here, we'll have minus 2. Now minus negative x here is adding x. So we have
X squared.
adding x over here, okay? On the other side, so negative 4 times x is negative 32x. Negative 4 times 3 is negative 12. Okay. Now after that, you will simplify inside the bracket here first before you distribute the 6. So here, x plus x is 2x and then minus 2 over here. Now you distribute the 6. Distribute over here, we get 12x minus 12. Now we want to get the x on this side and number on the other side. So let's first get this number. Let's cancel out this subtraction with 12 by adding 12. So we add 12 on both sides. That way, this is canceled out. These two are canceled out. And also these two cancel out too, okay? Now we get 12x equal negative 32x. We want to have the extreme on the left side only. So we will add 32x on this side. So to cancel out this, we also need to add 32x on the other side, on both sides. So we add 32x on both sides. That way, all the extreme will be on the left side. Now these two add up to 0. These two add up to 44x. To solve for x here, we need to undo this multiplication because this is 44 times x. Undo multiplication, we divide. So we divide 44 on both sides. Now, 44 divided by 44, we divide out. 0 divided by 44 is going to be 0. So x is going to be equal to 0. So that's the final answer here. Now this next equation. To solve this equation, we want to get rid of the denominator. So think about the LCD. The smallest multiple of 3, 4, 12 is going to be 12. So that's the LCD. So we multiply by 12 on both sides. So 12 times 1/3. So we'll reduce and you get 4. 12 over 4 is 3. 12 over 12 is 1. Okay. So over here, you end up with 4 times this in the parentheses. 3 times 5x is 15x. And then this, you got 31. Now you distribute over here. Okay. Now to distribute here, 4 times 2x is 8x. 4 times negative 1 is negative 4. Okay. Now I want this x on the left side. So I need to get rid of this 15x on the right side of the equation. So I will subtract 15x on both sides. And that will give me negative 7x. Okay, here minus 4 equal to 31. And I want the number on the other side. So we get rid of this number. So we will have 4 over here. Okay. So that way you will have, this side you have 35. Now to solve for x, undo this multiplication with divide by -7. What's 35 divided by -7? Anyone?
-5.
Five.
-5.
You got it. -5. X equal -5. Okay, good job. Okay, the next equation. Okay, for this equation over here, so 5 to 5, the smallest multiple will be 10. So the LCD here will be 10. So we multiply both sides by 10. Okay, multiply both sides by 10 over here. Okay, so now 10 over 5 is 2. 10 over 2 is 5.
10 over 5 is 2.
Now over here we will have 2 times 8 over here. We'll get 16. Yeah, you got it. And then here's -5 times. Now you keep the parenthesis over here. X plus 9. Okay. So this -5 need to be distributed with the x and also the 9. Okay. So I still keep the parenthesis here. Okay. Similarly, this 2 over here. Okay, so we have this 2. Okay. And actually, I can go ahead and distribute right now. Okay, so we distribute the 2 here times this. Actually, over here, I can try to go ahead and distribute right now. So I'm going to erase this. Okay, so I'm going to distribute this -5 inside this parenthesis. -5 times x is -5x. -5 times 9 is -45. Okay. Now over here, you distribute the 2. 2 times x is 2x. Plus 2 times 2 is 4. Okay. And over here, -10 times 4x is -40x. Okay. Now, we will simplify the left side and the right side separately. Okay. So this one over here, we have 16. So the two right chains over here will be this 16 minus 45. What's 16 minus 45?
29.
Negative. Yeah, negative 29.
29.
Yeah, -29. Okay. And then over here it is -5x. Okay. And then on the right side you have this 2x minus 40x, you get -38x. And then plus 4 over here. Now I want to have the x on the left side equation. So I will get rid of this -38x on the right side by adding 38x on both sides equation. Now, and then I want the number to be on the right side of the equation. So I need to get rid of this number on the left side equation. So I add 29 on both sides equation. Okay. Now by doing this, so this 2, okay, what's -5x adding 38x?
33.
Oh, you say 33x? Yeah,
Yeah,
you got it.
33.
Yes, you got it. Okay. So 33x, okay. And then now this 2 cancel. And then this 2 cancel. And this 2 add up to 33. Now what do I do?
You
Divide both sides by 33, right? So divide both sides by 33, x is equal to 1, right? Okay. Okay. All right. So the next one over here I'm going to cover will be decimal. I'm trying to go over how to solve equation with decimal. So it will be easier if you have those convert those decimal into integer. Okay. So if you multiply, say, this number here by 10, you move the decimal point 1 place to the right. You still get 1 digit here after the decimal point. However, you times 100, you move the decimal point 2 places to the right. Now you get an integer. Okay. So depends on how many digits after this decimal point, and then you multiply that by some power of 10 over here. So over here we times 100. Okay. This one here we have 2 digits after the decimal point. So for all of this, so we times 100 on both side equation. We times this 100 on this side equation. Now 0.04 times 100, move the decimal point 2 places. Then you get 4. And then you just use the 4 here times the 12. Now some of you might ask me, how come you don't use this 100 times the 12 over here? Now think about this, okay? Say if you have 2 times 3 times 4, okay? Suppose you have a parenthesis over here with the 4, but still multiplication, right? The way that you do it is 2 times 3 will get 6. And then the 2 is not going to multiply with the 4 again, okay? Because now then you use the 6 over here to multiply with the 4, okay? So you don't use the 2 times the 4 again because distributive is not over multiplication, okay? You only distribute over addition inside the parenthesis, okay? So similar here, when you have this 100 times this 0.04 times 12, then 100 times this will give you 4, and then later you just use the 4 times the 12. So you don't use the 100 times the 12 again, okay? Okay, so here you get 4 times 12, just like that, okay? And here, move the decimal point 2 places to the right, you get 1x, which is this x, okay? And here you will just get 2. Move the decimal point 2 places to the right. Now, over here, you need to distribute this 2 inside the parenthesis over this addition. Okay, you distribute over addition. Okay, this is addition here. Over addition or subtraction. So this is addition. Okay, so you distribute over. So this side here, you will get 24 plus 2x. Okay, and then on this side, you get, this is 48 plus x. Okay. Now, because this coefficient for x here is larger than this coefficient for x here, the coefficient is 2, coefficient here is 1, right? I would like to have the x on this side, okay? So I want to have the x on the side that has a larger coefficient on x. So because I want to end up with a positive coefficient for x, so I want to get rid of this x on the left side. So I will subtract x. That way, 2x minus x here will just get x. Okay. And then over here, you get 48. And this is 24 plus x. So you get positive coefficient for x over here. Okay. Now, I would like to have the number on the other side. Okay. So you get rid of this 24 here by subtract 24 on both sides. So you will subtract 24 over here. So 48 subtract 24 is what?
24.
24, yes. So 24. So x equal to 24. Okay. All right. Question? Okay.
I have a question.
Yeah, go ahead.
So whenever there's decimals, is always an option.
Yeah, it's an option. You can actually work with decimal. You can keep the decimal because nowadays you use calculator. It's actually not much harder if you work with decimal. So it's an option. So you can either get with the decimal by multiply both sides by power of 10, or you can work with the decimal. Either way.
Okay, good.
Yeah.
Thank
okay,
you.
Good question. Okay. You raise your hand. So, Ethan, or you have questions?
Yeah. Oh, it was just over the decimal, but I think she explained it. But if you could solve one without changing the decimal, if we have time, I'd like to see that.
Ah, okay. Sure. So you want to see how to solve this to work with decimal, right? Okay.
Yeah.
So I'm going to see if I can I'm going to add that one page over here. Place 3. Oh, I'm going to go over that. Okay, so 0.04 times 12 plus 0.01 times x equal to 0.02 times 12 plus x. So the same equation. Okay. Now to work with decimal, you will multiply this. So this is going to become 48. You can use calculator, but you can also do that manually. Okay. So 48, and there are 2 decimal points. So it's
48.
now plus 0.01x. Now over here you distribute. Okay. So this 2 multiplied is 0.24, and then plus 0.02x. Okay. So you just go ahead and distribute this. You get 0.24 and distribute here is 0.02x. Okay. Now after that, I see that this one has the coefficient for x here is larger than the coefficient for x here. I want to keep the x on this side. So I need to get rid of the x over here. So I will subtract 0.01x over here on both sides. Okay. Now by doing this, I will end up with 0.48, okay, equal to 0.24 plus what's 0.02x minus 0.01x. This is going to be 0.01x over here, right? Now you have this x on this side, and you want to keep the number. You want to have the number on the other side. So let's get rid of this number on this side. So we will subtract 0.24 on both sides. Now that will cancel, and that will give me 0.01x on this side, and this side over here I get 0.24. Okay. Now to solve for x here, and notice that this is multiplication. To undo multiplication, we divide. So we're going to divide by 0.01 on both sides. You can use your calculator, or you can just do it manually. Okay. So this is going to be x. Now this 2 divide by 0.01 is the same as multiply by 100. So you move the decimal point 2 places to the right. So you get 24. So this is 24 over here. So you get the same result, x equal 24. So there are 2 ways to do this. Does that answer your question?
Yes, that was perfect. Thank you.
All right. Okay, good. Okay, so the next one. Okay. Now for number 6 over here. Okay. This one over here, we will first distribute this inside the parenthesis over this subtraction. Okay. So we'll have negative 2x. What about this negative 2 times negative 1? So that will become positive 2, right? You add 2, right? So you add 2 over here. Over here, you also distribute, okay? So negative 4 here, distribute, you get negative 4x. And here you copy. Now you combine line chain on the left side. You get negative 2x. 2 minus 4 is negative 2. And on the right side, negative 4 plus 2 is negative 2. So I'm going to put negative 2 here. Negative 4x plus 2x is what? Negative
X.
negative 2x, yes. Now, do you guys observe about something interesting about this equation? What do you observe about the left side and the right side of this equation? What do you see?
They're the same.
They are the same, right? They are identical on both sides of the equation. So this is an equation that we call an identity equation. So this is an identity, okay? So both sides are identical, okay? Now, because, now let's look at this equation right here. So what can I plug into x to make the left side equal to the right side, to make this equation true? Now, because they are identical, okay, I plug in 0 into x. Will the left side equal to the right side? Yes, right? So because they're identical, if I plug in x over here, the left side will still be equal to the right side. If I plug in half, left side to equal right side. Plug any number into x over here. The left side will equal to the right side. So you can actually plug in all real number, any real number. So all the real numbers will work. Now, because this original equation, okay, is equivalent to this equation, so this original equation, we have the same result. So the solution for this original equation will be all real numbers. Okay, any real number it's going to work. Okay, it's going to work. Okay, question about this? Now this equation here is an identity. The left side and right side are identical. Then the solution will be all real number. Okay. Now some of you might ask, can I continue to reduce this equation? Because you kind of feel uneasy. I still have the x over here, right? Okay. So can I continue? So if I continue to reduce it, I can add 2 on both sides of the equation. Then I end up with negative 2x here, and then negative 2x on the right side. Both sides are still identical. So again, I get an identity. Then the answer will be all real numbers. Now some of you said, can I continue to reduce this further by adding 2x on both sides? Yes, you can do that. So I add 2x on both sides of the equation. That way, this 2 cancel, you get 0. This 2 cancel, you get 0. You get 0 equal to 0. It isn't, okay, both sides are the same, right? So again, this is an identity. So the answer here will be all real numbers. You still get the same answer. So you don't need to reduce that further. If you see the equation here, the left side and the right side are identical, then you can go ahead and say all real numbers.
Amazon package will be delivered today.
I'm sorry, my echo show just give me the message. It's the interruption. Okay, my Alexa just gave me the message. Okay. Okay, so over here, so the answer here will be all real numbers. Okay. Okay. Now, when you solve the equation, I'll make a read mark here. When you end up with an identity, such as one of this, both sides are the same, both sides are identical. The answer here will be all real numbers. And the solution set will consist of all real numbers. There's a fancy notation for the set of all real numbers. Real start with R, so you put a capital R over here, but you make this double bar over here. So this double bar R stands for the set of all real numbers. So in the future, you can just put this double bar R for all real numbers. Okay. Okay, the next one over here. Okay. This one over here, we have this, we first distribute here. Okay. Let's choose to convert the decimal into integers. Okay. So we will multiply. Now here you see this is only one digit after the decimal point, right? For this and this one and this one. So we multiply by 10 on both sides. Times 10 on both sides, you move this decimal point one place to the right. So this will be negative 62. And this one here will be 42. This is, now don't forget here, okay? You times 10 with every term on both sides of the equation. So negative 4 times 10 will be negative 40, right? Okay, now over here, minus 2x is the same as adding 2x. So you will try to go ahead and rewrite this as adding 2x first, and then use the 2x here, multiply with the 10. 2x times 10 will be 20x. So you have 20x over here. Okay. Now what do I do? You will distribute, right? So let's go ahead and distribute here. Distribute this. Everybody, any answer this? What do I get over here? What do I get the next step? Everyone?
62x
62x.
62x
Right.
plus 62.
Plus 62. Good job. Okay. Because negative times negative is positive. Okay. So keep adding here. Okay. On the right side, these two are 9/10, right? Both have the x here. So combined by adding the coefficient, we get 62x here. Now simplify the left side equation. 62 minus 40 is 22. Okay. Now we will subtract 62x on both sides. Okay. So let's say subtract 62x on both sides. So that will cancel, okay? And leaving you with 22 here. Now these two cancel, you get 0. Can 22 equal to 0? There are two different numbers. No, yeah. There are two different numbers. They cannot be equal, okay? So this is impossible. So when you have two different numbers equal to each other, okay? This equation here is a contradiction, okay? So in Chinese, we call that the sword and the shield. This is in Chinese, okay? So impossible, okay? So now notice that this contradiction equation, this equation come from this original equation. So they're equivalent. So if this is impossible, then this original equation here will be impossible, okay? So we will have no solution. Okay. Should I have an S over here so when I say no solution? Okay, maybe I should put an S here, right? So we have no solution. Okay. So no solutions. So the solutions that we have nothing in it. Okay. So fancy this notation here I show you is called the empty set notation. So the set will have nothing in it. So it's like a 0 with a slash. Okay, think about it like an empty basket. There's nothing in it, not even 0 in it. So you have a solution to be 0. You have one solution. You have 0 inside the set. But this one here has nothing, not even 0. Okay, so it's like an empty set. It's an empty set. There's no solution in it. Okay. So I make a remark over here. When you solve an equation, when you end up with a contradiction. So what do you mean a contradiction? So this is a contradiction. Two different numbers are equal. Okay. This is actually a contradiction also, but you don't see that right away. Okay. Until you simplify, you get to this step, you see that it's a contradiction. So when you simplify the equation, okay, and you end up with two different numbers on both sides of the equation, that is a contradiction. And the answer for that will be no solution. And you can put down the solution set as this empty set. Okay, it's 0 with a slash. That's the empty set. So I'm going to test you guys, see if you guys understand this. I have two equations here. This equation here is an identity or a contradiction?
Identity.
Yes, this is an identity. Okay. So this one over here, it is an identity. Okay, what about this?
No solution.
No, yeah, the answer here is no solution. And the equation here is a contradiction, right? Contradiction. Okay. So the answer for the for this, okay. Now for identity, the answer will be what? What's the answer for an identity equation? Anyone? Do you remember?
All real number.
All with numbers. Yes, very good. So you put down this all with a double bar, and this stands for, this is the set notation for all real numbers. Okay. Now, if you end up with a contradiction, right? So what's the answer here?
No solution.
No solution. Yes. So we have no solution. Okay. And the solution set will be the empty set. So 0 with a slash. So we are done today.
I have a question. Do you want us to do the empty, like the 0 with the slash instead of the no solution or both?
If they ask for solution set, okay, if they ask for solution set, then you put down the set notation, this one and this one, okay? And if they ask you to write the word, and then you will put down all real numbers or no solutions. I think in website, for your homework, they probably had this no solutions or all real numbers. Okay, but I show you both ways. So if they ask you for the set, solution set, then we use this too. If they have this, they ask you to write it in Word, we have this. Okay, when you do homework on website, you see which one. Depends what they give you. Okay, sometimes they give you this, sometimes they give you this word, those words. Okay, so it depends which one they gave you. Okay. All right, so I'm done with the lesson today.